All right, we're going to talk about section classification, and I've pulled a couple tables here directly out of the ACI code so that I can annotate those as we go. The main one here is table R24.5.2.1, and this describes how we know which pieces of the code govern what section we're doing. So until this time, we've pretty much hung out in this non-pre-stressed section. So this column, this last column, is what we did for our reinforced concrete class. And now we've moved on to the pre-stressed part, which is this piece. And there are three sections that are under the pre-stress. There's class U, class T, and class C. U are uncracked sections, T are transition sections, and C are cracked sections. So U, uncracked, T, transition, and C, cracked. It used to be in the code we pretty much had pre-stress or non-pre-stress. Pre-stress is not that simple in that the section can be in a couple different stages as you go through. So if you put enough pre-stressing in and balance it well with the loads, you can have a section that remains uncracked under service. And that's really the section that we're talking about in this class. This is the normal kind of fully pre-stressed section. A crack section is one that really acts a lot like a reinforced concrete section, but maybe has some pre-stress in it that helps it overcome some of the loads. So when you load it up and you're in service, that type of section, a crack section, is actually going to have cracks in it as a concrete section would, and you're going to have to do deflections the same as the concrete, and you're going to have to use the crack section for a lot of your calculations and things like that. The transition section is one that's kind of between the two. It may or may not crack. It's in a place where the tensile stresses at the service load are somewhere between the modulus of rupture, which is our theoretical cracking piece, and what is a little bit higher value where we think probably isn't necessarily cracked, but it's right between the two, which the code's not going to let you get away with that as far as calling that a totally uncracked section. So I want to spend our time here talking about this table in pre-stress class U. So this is our uncracked pre-stress section, which is what we will be designing in this class. And we'll be checking to make sure. So what happens is for these uncracked sections, so we're assuming our behavior is uncracked, to make sure that happens, it has to follow the guidelines in this column. And it tells you what sections you'd also use for the different types of calculations. So the second row says section properties for stress calculations at service. You get to use IG, the gross section. Allowable stress at transfer, we're going to refer to this section of the code. Likewise, compression. Tensile stress, this is going to be our limit at 7.5 square root of F prime C. Okay, and that you might look kind of familiar. That's the modulus of rupture. So we're going to compare to that tensile stress. And deflections, it refers to your sections here, but basically you're going to get to use gross section properties. That's a big deal because you remember over here in the non-pre-stress, we had to use effective moment of inertia, calculate cracked moment of inertia, and all these things. That section of pre-stress is much easier. There's no crack control requirement because it's not cracked. And thus you don't have to calculate the pieces that go with it. And side skin is something that you probably would talk more about in a more advanced traditional reinforced concrete class, or perhaps a senior design type class. But there's no requirement for additional reinforcement along the edges, along the skin of the concrete, because basically we're keeping in compression from that P over A force all along the section. All right, so let's take a little deeper look at what some of these sections refer to so that we can look at what our stress limits are. If we take a look at table 24.5.3.1, this is the concrete compressive stress limits immediately after transfer. So this is at transfer of pre-stress, and then the next table is tensile stress limits. I should probably highlight the compressive. Tensile stress limits immediately after transfer. Okay. It says without additional bonded reinforcement of the tension zone. Again, that's a kind of a special case, and so right now we're just looking at what these limits are. And then we have concrete compressive stress at service, and then this is a little strange how this is done, but the tensile stress at service is already in the table out because it's one of the things you use in the table to figure out what kind of section it is. All right, so what this means is you're going to be looking at that stress equation, your stresses in the top or the bottom. You're going to calculate those values, and you're going to use a force P at transfer, which is called P sub I, and you'll use a different force when you're at service, which is P sub E. I like to put P effective because otherwise P times E looks a little bit too much like that. So you'll actually use a different pre-stress force at the different levels, and we talked a little bit about losses in the beginning, and we'll do a section where we calculate those, but that's the difference. So you're going to run this stress calculation for top and bottom, which will give you the compression and tension typically, and you'll look at that at transfer and service, and the values listed in each of these tables are the governing. So these values, and we will go through and summarize these in class one more time, but take a good look at this table before you come to class.